Welcome to Qt Widgets and more. In today's episode, we'll look at all the hard work that your compiler needs to do. Let's start with a test. How many lines of code does your compiler need to look at for a simple main.cpp? Or how about if you include Qt test rather than just Qtest, as we saw a few episodes back? How much more work is that? Or finally, if you use the module include of Qt widget, or widgets I think it's called, rather than just including QComboBox, QLineIt, whatever you need, how much more work is that for your compiler? That I'll answer in this episode of Qt Widgets and more. So welcome. $84,000, 50% and 50%. There you are. Now you have the answers to the quiz. You don't need to watch much more. Or if you do, what this episode is really about is -E given to your compiler. That will show you the output after your preprocessor has run. If you're one of those young kids out there that knows about C++ but never really thought too much about the preprocessor, well, I can tell you that before your real compiler is given the source code, it will have the source code run through a preprocessor. That is the one that knows about macros and knows about the if-defs and all of those things. But let's start out looking at a really weird compilation error. So let's compile this very simple example that I have here. And you can see that it says unknown type name foo. And let's just double click on that error to see what exactly are we looking at here. And given that this is a really minimalistic example for your purpose, it should be relatively easy to figure out. But nevertheless, try and walk with me and pause if you need to ponder about it. I have a class bar here, and there's protection up here with ifdef and indef as usual. My bar takes a foo pointer as its parameter, and we can see that I include foo.h. So let's have a look at foo.h. Foo.h implements the class foo here. So unknown type name foo, but I do have the foo here. That is slightly puzzling. But let's read on. The foo has a constructor, it takes a bar pointer, that's cool. It has a child, so something with a parent-child relationship. Pause. Did you spot the line? The problem is line 4. So in line 4 I include bar.h, and the first thing that I meet here is include foo.h, and that includes bar.h and foo.h and so on. And of course it doesn't continue like this. What happens is that whenever, and let's look down here, what am I trying to compile? I'm trying to compile foo.cpp. Can I make this bigger? I'm sure I one day saw that. I cannot figure out how to make it bigger. I'll tell you what it says here. It says in file included from cpp macros foo.cpp. So foo.cpp, that's the one that I want to compile. It includes foo.h. When it does that, it sets this foo_h right away. It continues on including bar.h, and the bar sets this hash mark or this bar_h right away. Then it includes foo.h, but when it gets to foo.h, it sees, yeah, nothing to do. I already have foo_h defined. So let's go back now and continue on, and it gets down into the compilation of bar. And that's when it sees this foo that it doesn't know about, because I never got that far when I included foo.h. Hopefully you won't make that mistake, but it's always useful to see what is given to the compiler after the pre-compilation stage, especially if you have some complex macros in there that is difficult to see how exactly did that expand. And for that, I'll show you a trick. It works with GCC and Clang. So if you're on Visual Studio or the Microsoft Visual Studio compiler, I honestly don't know how to do it there, but somebody please add a comment below if you know. The trick is simply to add -E to the compile command that will spit out and stop right after the pre-compilation step. So I'm in the shell here now. Let's run qmake to compile the code, and compiling it. Let's just compile it once more so that we have fewer lines. Remember, it was in foo.cpp. Over here in my shell, it says unknown type name foo when I was trying to compile foo.cpp and so on. So in foo.cpp, it tried to include eventually bar.h, and we had this class bar that it didn't know about. Over here, and foo.cpp, that's a compile line we have right here. Cut and paste that, go back and remove the -o and change that to a minus capital E. Run that through less. Let's actually go to the bottom of the file here and see how many lines we're talking about. 58,000 lines of code for some super trivial. Where did all that come from? Well, you can go down and look at the includes here and see what it's operating on. It is lots and lots of different includes that comes from C++ itself. But let's have a look at class bar, see if we can find that. On line 23,040, we can see class bar. Yeah, that looks about right. But how about class foo? And you'll notice that one shows up only on line 58,000. So what was the other one? 23. Well, I can't remember the number, but way further up in the file, I had the definition of bar where I was using foo. And if we want to look further in, I can see that I'm in foo.cpp on the start of it. It includes foo.h. So now I'm over in foo.h, which includes bar.h, and then we'll stop here, and I'm now going through bar.h and include all of those things. Very useful. So simply compile your stuff and replace the -o and file name with a minus capital E. So if you're using qmake, there is a flag, as you can see here, that you can specify. And if you do so, then running make will actually leave a bunch of files behind, namely files ending in .ii. And to show you the answer to how many lines are there in a simple main.cpp, 86,111, and you can see here, this is what the pre-processed step looks like. There's also main.s in case you want to see that. So that's the assembler code generated, but let's not even go there. That was qmake, and I doubt that you want it all the time to spit out these additional files. So when you have these weird situations, simply go and cut and paste in your shell. If you're using cmake and you're using make, that is not Ninja. So cmake plus make, then there is a small little trick that I'll show you next. So I cleaned out the build directory again, running cmake, running make, and as you'll notice, it doesn't print out the error line anymore, which is, how do I get to that? Well, first thing you could do is you could run verbose equal to 1, run make, and here is your command lines again. Or you can run a special target make, or is it foo.cpp.i or s, and what you'll get out of this, somewhere else located, I admit, but nevertheless, here we go. And here is your pre-processed file. Very nifty. I can never remember that it's called .i, so simply it is the foo.cpp file or foo.whatever. Here you can see all the targets, foo.i. I wonder what's the difference between, oh, it's still the same one. Okay. If you watched my episode on speeding up compilation, you'd know that I would argue to use Ninja rather than make, which is fair enough. You might have your reasons for still using make. But if you're using Ninja, unfortunately, the Ninja generator from CMake do not spit out the .i target. In that situation, you're back to figuring out what is the compilation line and just cut and pasting. I can never remember the exact arguments to CMake to make it into a Ninja version. So I have this alias CMake minus Ninja, and it goes like this. Feel free to go ahead and steal that alias. CMake minus Ninja ... and here we are. I'm ready to compile Ninja, and you can see it's compiling, and it's actually nice enough to tell me exactly what was the errorness line. That's this one here. Go and find the -O, which sits there, and cut and paste. But imagine that there was no errors, then it would just print out. Let me just Ninja clean again, and you at least have a microsecond where you can see what is going on. You can see it just says building, and that was the line that you saw up here, where it would have counted up until 8 had there not been any errors. In that situation, what you need is to type clean correctly and then run Ninja -v for verbose, and that spits out all the command lines. So if I wanted to see main.cpp, for example, well, Ninja clean, of course. There we are. And here is my exact line for Ninja execution of Clang for main.cpp. And sorry for just stuttering there for a second. I was just remembering to tell you Ninja clean and run instead of Ninja -v. You might be tempted at looking at verbose equal to 1 Ninja, but that doesn't tell you what argument that is actually calling. It tells you the steps that CMake itself takes internally. So that's something completely different. With make, you would want to do them verbose, but with CMake or with Ninja, you actually want the -v when you compile. Slightly confusing, but now you have it. Just take a note on a piece of paper and you'll never forget again. Before I leave you, I'd like to go to Qt Creator and show you how you can see macros expanded inside of Qt Creator, but more importantly, how you can disable that, because to me, it's just way too often I have a gigantic tooltip covering my code for the odd situations where I actually want to see that tooltip. So inside Qt Creator, all you need to do is move your cursor on top of a macro like Q_object here to see a tooltip with the information about this one. But it's annoying when you're sitting somewhere here and you want to type and you just move your cursor array and you start typing and all of a sudden you have that tooltip. At least I find that's super annoying. So tools, options, as so many times before, search for tooltips, and it shows up in the text editor. And down here it just says show help tooltips using the mouse. And now you can change it to unshift mouse over. I never use unshift mouse over either, but I use this one here, show help tooltips using keyboard shortcut Alt. And I wonder that's just weird to use Alt key, but nevertheless, okay with this here. And see no tooltip here anymore. I can press the shift down. Sometimes it works. Maybe I should move in for it to work. There we are. But the Alt key actually works at least all the time. I'm just here. I want to know. I press the Alt key and of course no tooltip shows up because now I got my menus selected up here. But if I press the Alt key and I press the Alt key once again to make that go away, then I'll see the tooltip. And that works for anything in here, Alt. And now I can see that this is a UI main window that's 8 byte long. And that's pretty neat. That's it for this episode of Qt Widgets and More. You heard the more part, right? That's actually what this was about. It's one of those small tricks that I'm puzzled every time I meet a youngster that really have never been to the shell, but mostly use the IDE and doesn't know about this option, because it's not one of those that you will be using every single day, but it's a very, very useful one to go and look at from time to time. And we didn't even get to look at Qt test how much additional that was, but it was order of magnitude, if I remember correct, so go check it out, 30,000 lines of extra code that your compiler needs to go through. That's a lot of work. No surprise that it takes your compiler so long to compile simple files. I hope you enjoyed this episode. Do leave comments below, and well, until next time, have a great time. Wait, there's more. On June 13th to 15th, KDAB is going to host a Qt Developer Conference in Berlin, in person. I'll be there, and I hope you'll be there too. Check out the program below. Trust me, there is going to be something super interesting for widgets developers too.